Hello class, this video will be covering the second half of lesson 10.3. We already talked about experimental probability, which is, for example, I use the example of if we actually flipped a coin 50 times, we would record how many out of the 50 times we would, for example, get a head. Today, we are talking about when all the possible outcomes are equally likely. So equally likely meaning we have a head and a tail. Flipping that, we have a 50-50 shot of getting head, 50-50 shot of getting a tail, right? So they're equally likely. The theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible total outcomes. Okay, so if we are going to still use the same flipping a coin example, the number of possible outcomes we have on when we flip a coin is 2, right? We have a head and we have a tail. And say we wanted the event of flipping a head, the favorable outcome, there's only 1, right? So our theoretical probability of flipping a coin and getting a head would be 1/2. Let's take a look at the examples the book gives. It says, you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Okay, so you want to kind of separate the two ideas of experimental and theoretical and differentiate the two. So experimental would be if we're actually picking this, saying we're doing this trial 20 times, okay? Theoretical would be just kind of what we would expect to happen, okay? Like in a perfect world. Okay, so we have number of possible outcomes. So we have 1, 2, 3, 4, 5, 6, 7 blocks we could pick from, so there are 7 possible outcomes. Okay, now we have to look at all the vowels. We have 1 vowel, 2 vowel, 3 vowel. Okay, so the number of favorable outcomes, there are 3. So the theoretical probability is 3/7. Okay, if we're comparing this to the experimental probability, it would be the number of times that the experiment happened, right? So it would be the 25 times, and maybe we picked a vowel 10 of those 25 times. Okay, so let's see if you can start kind of differentiating between the two. Next, it says, what is the theoretical probability of choosing an X? Well, again, there are 7 blocks, so there are 7 possible outcomes, and there's only, I'll use a different color, 1 X, so the theoretical probability of choosing X is 1/7. Okay, now let's see if we can use the theoretical probability. Okay, so it says the theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 3 bobblehead sections. How many sections are on the wheel? So what they pretty much gave us is that this theoretical probability, this fraction of 1/6, this is the fraction simplified. Okay, so if we have 1 favorable outcome for every 6 total possibilities, okay, that's what it would look like. Okay, so there are 1 bobblehead section, and the total number of sections would be 6. But now it's saying it actually has 3 bobblehead sections. We need to find out how many sections total are on the wheel. So we set up a proportion once again. Okay, we can cross multiply and get 1s is equal to 6 times 3, so we get 18. So there are 18 sections total. Okay? That makes sense because 3 out of 18 is equal to 1/6. Okay, so what happened here is that there were actually 3 bobblehead sections out of the total 18 sections. So this is the theoretical probability of spinning a bobblehead section, okay, and then they just simplified it to 1/6. So we had to kind of unsimplify by using cross products. Okay, next, the theoretical probability of spinning an odd number is 0.6, 6/10. The spinner has 10 sections. How many sections have odd numbers? Okay, so I'm going to first translate this decimal to a fraction. This is 6/10, so I know as a fraction 6/10 is written as 6/10. Okay, the spinner has 10 sections. Okay, so we have 10 sections total. You know that the total number of sections goes on the bottom, 10. how many sections have odd numbers, and we get 6 on the top. So we already had this simplified. We didn't have to do any unsimplifying like with cross products. So we just know that there are 6 odd numbers, okay, and 10 total sections. The prize wheel was spun 540 times at a baseball game. About how many bobbleheads would you expect there won? Okay, so for this one, we know that the total times it spun was 540. Okay. And we want to know, of those 540 times, how many would we expect? Okay, so if we go back up to letter A, we have the theoretical probability of winning a bobblehead is 1/6. So we're going to use that same theoretical probability of knowing that for every 6 times you spin the wheel, one of those times you would get a bobblehead. Okay, so we're going to set up this proportion, cross multiply. So we get 6x is equal to 540. Divide both sides by 6. Okay, and get x is equal to 90. Okay, so we would expect 90 times out of those 540 to get a bobblehead. Okay, and next we are going to get to kind of comparing the theoretical and experimental probability. Okay, so we covered experimental probability last time. Now we're looking at theoretical probability. Okay, so it says find the experimental probability of rolling a number greater than 1. Compare the experimental probability to the theoretical probability of rolling a number greater than 1. Okay, so let's just do the theoretical probability first, because that's what we learned today. And then we will look at the experimental. Okay, so if we are rolling a number cube, we again look at our number of favorable outcomes over the total possible outcomes. Okay, so the total possible outcomes when we are rolling a number cube are 6, because we have 1 through 6. Okay, number of favorable outcomes, so we have 1, 2, 3, 4, 5, 6, and we want a number greater than 1, so it would be those 5 numbers. So the theoretical probability would be 5/6. Now, when we're looking at experimental probability, we have a chart that summarizes the number of times rolled. Somebody actually did this experiment, but we don't know how many times they did this experiment. We have to count it up. So the total number of times, remember, goes in the denominator, okay? So we need to add up all of these rolls in the denominator. 48 plus 53 plus 50 plus 52 plus 49 plus 48. And when you do that, you should get 300. Okay, so that's the total number of times they actually rolled. Okay, now we need to find the experimental probability of rolling a number of greater than 1. So the favorable outcomes here are rolling a 2, a 3, a 4, a 5, or a 6. So we need to add up all of those. So 53 plus 50 plus 52 plus 49 plus 48. And when you add those up, you should get 252. Okay, so now to kind of compare, I'm just going to make these both decimals. Okay, so I'm going to do 5 divided by 6 and get 0.83. And that translates to 83. So in a theoretical world, 83% of the time you would expect to roll a number greater than 1. But this experiment told us that when we rolled the cube 300 times, 252 out of those 300 times, you got a number greater than 1, so that's 0.84, which is 84%. Okay, so as you can see, the theoretical and experimental probabilities are very similar. And this is because we had a high number of trials. Okay, so the more trials you do, the closer your experimental probability will match your theoretical probability. If you only rolled this cube maybe 10 times, maybe only 2 of those times you got a number greater than 1. Maybe you just got lucky and you got a bunch of 1s that first time. That's why you want to do as many trials as you can, because then it will match your theoretical probability more.